let's convert 37 to base 10 to base 8 numerals. So this is the question. We are converting from 37 to base 10 to base 8 numerals. So we are converting from 37 to base 10 to base 8 numerals. So when it happens like this, we are saying that always know the digits. That is in base 10. Secondly, you have to also know the base that you want to convert that digit into. So there are two cases here. You can see that now our digits here, digits is 372. Then the base we want to convert to is 8. So this is our digit, and this is the base that we want to convert this to. So step 1, you should be able to identify the digit and the base that you want to convert into. Now you move to step 2. Step 2, you have to create a column, 3 columns. So this is my 3 column. Now the first column should be the base that you want to convert into. So in this case, we want to convert the 372 base 10 into which base? 8. So here will be 8. Now the second column becomes the digits. And what's our digits here? 372. Then the last column is for what? The remainder. Now here we apply something we call the repeated division. The repeated division in this case is that we are going to use the base that we want to convert it to divide the digit in such a way that at the end of the day, any division that we do, when it divides it exactly, it means we have a remainder of what? 0. But if the number is not able to divide it exactly, it means there should be a what? A remainder. Then we write the remainder and the remainder column. I hope it's clear. So we start the division. So now you have 372 is a huge number. And we are using 8 to divide. So what do? It means you have 372 items and 8 people are going to share that item. Each person is going to get how many? So here, with the use of the calculator, you have to punch on the calculator 372 divided by 8. What is the result on the calculator? 46. The calculator is giving you 46 point what? 5. Bear in mind that here we are doing the divisibility we are doing here, we want exact value. Are you following? So this is telling us that we pick the whole number and multiply it by the base. So here the whole part is 46. So let's multiply 46 by 8. 3, 6, what? 8. Now what do we have here? 3, 7, what? Then you subtract this one from it. 3, 6, what? 8. What will be the remainder? 4. So this is telling us that the results, the quotient, if 8 people are sharing 372 items, each person is supposed to get what? 46, which is 368. Remaining what? 4. Now, don't forget that we are saying that we are using the base that we are converting into to divide the digits until we get to a point that the quotient that we are going to get here will be less than the base, then we pause. So here 46 you compare to 8. Is 46 less than 8? No, it means the division has to continue. So now we have reduced the 372 to 46. So if 8 people are going to share 46 items, so you go and do it again. In this case, it's 46 divided by 8. What will be the result? 5.75. So you pick the whole part and then you multiply it by your base. So if you multiply 5 by 8, what is the result? 40. But what do we have here? So your 46 minus 40 will give you what? 6. So this is telling us that if we have 46 items and 8 people are going to share that 46 items, each person is supposed to get what? 5. So if each person is going to get 5 and there are 8, it means 40 has been taken out. And the total item that you are sharing is what? 46. So it's left with what? 6. You put the 6. Are you following? Now we have gotten to this part. The answer here is what? And the base here is what? 8. So now we have 5 items. 8 people are going to share. Is it possible? So it means that there is no quotient. We have 5 items and 8 people are going to share. What will be the result? There is no quotient. If you divide, if you want each and every one to get something, then it means that either the number just should be equal to this or should be more than this. But in this case, what? It's less than the number of people that they are going to share. So we said there is no what? Quotient. We can't share it equally. So we put our 0. So since 8 people cannot share 5 items, what do we put here? 0. Means there is no quotient. It can be shared. Now how many left? How many are you holding so far? 5. We have not shared it. So we put the 5. So now the digit that we were converting is 372 base 10. Now we were converting it to base 8. So what we do is that you go to the remainder column and arrange the numbers from the bottom upwards. So you see the arrow. See where the arrow is going. So we are saying that this is equal to the results that we are going to get from here. But we are doing that by reading the numbers from the bottom going up, from the remainder column. So let's go to the remainder column. What do we have here? Followed by what? 6. Followed by what? 4. And what is the base that we are converting this digits to? Then you put the base. This is telling us that anytime we convert 564 base 8 into base 10, it is going to give us a result of 372. I hope it's correct. So these 5 steps are very key. First, identify the digits and the base that you want to convert to. Secondly, create 3 columns. But the first column should be the base that you want to convert to. The second column should be the digits. And the third column should be for the remainder. Then you apply your division method. You use the base that we are going to convert into to divide the digits to get to a point where we are going to get a result which is less than the base, then you pause. Just go to the remainder side and then record the values, arrange the values from the bottom upwards. And the value that we are going to get will be in the new base that you want to convert it. So at the end of the day, after, you can also try and see if the results that you are getting, if truly the results that you are getting is correct, then it means that if this is in base 10, this is in base 8, then we can convert from base 8 to base 10. Because of the equal to sign that we have introduced here, this means that 372 base 10 is the same as 564 base 8. If that's the case, then let's convert the 564 base 8 into base 10 and see if we are going to get the 372. So I have 564 here base 8. Then you go through the process again. Here we say that you label the place values starting from 0. So 0 we move to where? 1. We move to where? Then we said that we are going to pick the individual element here to multiply by the base. So what is the first element here? 5. Let's multiply by the base. 8. What is the exponent of the base here? 2. Plus, what is the next digit here? 6. Times the base. 8. Exponent. 1. Plus. 4. Times the base. 8. Exponent. 0. Now let's expand. 5 times 8 exponent 2 is the same as 8 times 8. What is the result? 60 plus 6 times 8 exponent 1 is the same as what? Plus 4 times 8 exponent 0 is what? It's 1. And we explain where that 1 is coming from. Do you remember? Do you remember that we explained where the 8 exponent 0 is 1? Where it is coming from? From indices. The second law, that is the division method. And in that case, we said that if we have a to the power n, and we are dividing it by a to the power n, what will be the results? We maintain one of the base and we subtract the exponent. Why? Because the bases here are all the same. So this is the same as a exponent n minus what? N. And that is giving us a to the power of 0. We did not conclude it from that place. Then we supported this statement with the example. If I have 3 exponent 5, and I divide 2 exponent 5, and I divide it by 2 exponent 5, by applying this concept, it's the same as 2 exponent 5 minus what? 0. Minus 5. And this is giving me 2 exponent what? 0. And we key in this into the calculator. What was the result? 1. Then we can conclude that all this is equal to 1 if the a here, the value here is not 0. So we concluded from that perspective that aside 0, any non-zero number, exponent 0, will give us a result of what? 1. So here is 1. From that one.
So let me say something. So with the a exponent m and then dividing a exponent m. In the law of indices, like we said, we have a exponent m minus what? M, is that not it? Now with that side, it's given from the right hand side, we have a to the power 0. But from the left hand side, the numerator and then the denominator, they are the same form. And it means that they will go into each other 1. So the left hand side is equal to 1, and the right hand side is a exponent 0. And that explains the fact that a exponent 0 is what? Is 1. Because when you have x over x, it's the same as 1. So a exponent m divided by a exponent m is the same as 1. But indices were able to convert that one to give us a exponent 0. So 1 is equivalent to a exponent 0. Meaning, any number to the power 0 is equal to what? 1. As simple as that.
I hope it's clear. Good. So now let's multiply 5 by 64. What is the result? 320 plus this times this 48 plus total results base. I hope it's clear. So we have done how to convert from any base to base 10. You get it? Then today, we have also learned another concept. What if the digit is already in base 10? And we have to convert it into any other base? What do you do? So always, I keep on telling you that math, for math, is a cumulative learning. So if you are someone that you are truant, understanding math will be very difficult for you. Like if you are consistent and you keep coming, there is no way that math you can really get it. What I have done today, I'm going to combine them. What if the digit here is not in base 10, but it is rather in base 5? What do we do? You see, what do we do? We have to go and convert this into what? Base 10. And we use the results to convert it into base what? 8. So, if you don't know how to convert it into base 10, and you don't understand how to convert base 10 to other bases, then in that case, what do you do? So you have to learn. You don't just come and go and throw the notes out. You have to revise. So we have more time. Let's continue. Case 3. So case 1, we converted from any other base to base 10. Case 2, we are now converting from base 10 to any other base. Now we want to convert between non-zero bases. In this case, the digit that we are considering here is not in base 10. Case 3. Good. So we are looking at conversion between the non-decimal bases. A case where the digit in this case is not in the same. But we are to convert it into other bases. We know from case 2 that we can only convert it into other bases when the digit is in base what? In base 10. So let's write. Convert convert 344 base 5 to a number base 8. Good. So in this case, can we go straight and construct the table? Can we move to case 2 straight? Why? Because the digit here is not in base 1, 10. I hope it's clear. Favor. I hope it's clear. We cannot construct the table now because the digit given in the question is not in base 1, 10. But we can convert it into base 1, base 10. So let's do so. Convert 344 base 5 to base 10. And how do we do that? We said the first step is that you pick each individual element and multiply it by the base. So in that case, we said identify the base. What is the base here? 5. So let's pick each element and multiply it by the base. And we said our base is what? 5. So 3 times 5. What is the next digit? 4 times the base. What is the next digit? Times the base. Good. So we said identify the base and multiply each individual element by the base. The second step is that we said we should separate the product of the individual element by the base by what? The addition sign. So this becomes 3 times 5. Then we introduce our subtraction sign, which is what? The plus sign. Plus 4 times 5 plus 4 times 5. Then the last step, we said we should assign an exponent to the base. You should assign a certain exponent to the base by starting from where? The right. Starting from the right to the left. Starting from where? 0. So this is the digit. And we are starting from my right to where? The left. Starting from 0. So if I start from 0 here, to the next one will be what? The next one will be what? 2. So assign this exponent to their corresponding base. So we are here. 3. What is the exponent there? 2. So the exponent here 2 is affecting the base. So the 3 and the 5 here, which of them is the base? 5. So we are here. What will be the exponent here? Here, what will be the exponent here? Yeah. Are you following? Good. Now we expand. So we have 3 times 5 exponent 2. And you know 5 exponent 2 is the same as what? 5 times what? 5. And 5 times 5 gives you what? 25. Plus 4 times 5 exponent 1. And 5 exponent 1 is the same as what? 5. Plus 4 times 5 exponent 0. 1. And you know why it is 1. Good. Now let's sum them up. 3 times 25. 70. Plus what? Giving us a total of what? 99. In this case, what will be the base? 10. Now that is in base 10, then it means we can convert. Now we can convert 9 base 10 to a number base what? Base what? 8. And in that case, what do? We go back to our case 1, 2. We said create 3 columns. What should be in the first column? 8. The base you want to convert into. And then the second column should be the digit. And that case, there's no more 3, 4, 4 base 5. But rather what? 99. Because the 99 is the one that's in this word. Then the last column is the remainder. And we are about to case 2. Easy. So we have 99 items, 8 people are going to share. So we do your divisibility. 99 over 8. We put it on the calculator. What is the result? 12.373. So let's take the 12 and multiply by the 8. 9 to what? So what do we have? 99. And what do we have here? So 99. Let's go and subtract 96 from 99. What will be the remainder? 3. So this is telling us that if 8 people are going to share 99 items, each person is going to get what? If each person gets one, it means we have taken 96 out. How many are going to? How many left so far? 3. You go and lay the prayer and remember that. Don't forget, we are doing it in such a way that the quotient that we are going to get here will be less than the base. Then we pause. But in this case, we are having a quotient of 12. Is it less than the base? No. Then please we have to continue. Now we have 12 items here and 8 people are going to share. Each person is going to get what? 1. So this is the same as you writing 12 over 8. And then what is the result? 1.5. So you pick the 1 here, multiply by 8. So this is telling us that each person is going to get 1. If each person gets 1, it means we have taken 8 out of what? 12. How many left? 4. What's the number here? Is it less than the base? Yes. So it means we can't divide. So there's no quotient. So what do we do here? 0. To represent that 8 cannot divide 1 exactly. So there's no quotient. How many do we have in our hand? So this is telling us that our 3, 4, 4 base 5 now into base 8 is what? We read from the bottom upward, from the remainder column. So what's the number here? Followed by what? Followed by what? In this case, what will be the base? Base what? 8. So we are done. Very simple. Is it not nice? So if you understand case 1 and case 2, you are good to go. So this is a combination of combining case 1 and then case 2. Okay. Example 2. Example 2. Example 2. Go through them, follow the procedure. Now let's convert. So try this one. Convert 432 base 5 to a number base 3. Go through the process. Convert 432 base 5 to a number base 3.